Hey guys, how's it going? Today we are going to go over section 1.8 where we are talking about unit rates, and basically we're going to keep working with proportions. So make sure you keep that in mind from last section as we tackle these new problems. All right, so why don't we go ahead and get started right away? So today's objectives are that we can use unit rates to solve real-world problems, and finally that we can solve a proportion, which actually that objective we kind of reached last section, but we want to make sure we understand it completely this time around as well. Okay, so right off the bat, let's go ahead and get started with what a unit rate is. So a unit rate is a ratio, let's write that down, a ratio per one given unit. Okay, so right now that might not make too much sense just yet, but we'll make a few examples here that will get you guys an idea of what that means. So as an example, I have right here a window car sticker at the dealership will read that a car drives 32 miles, so 32 miles per, okay, 1 gallon of gas. Okay, so what are we doing? We're comparing two things here. We are comparing miles per gallon, and like we said earlier, it's a ratio, miles over gallons, okay? And it's per one given unit, as it shows here, per 1 gallon of gas, okay? So let's actually go ahead and practice with a few problems so we can get a better understanding of what a unit rate is. All right, so let's go ahead and read this first problem together. So it says, at Walmart, it costs $8, and let me go ahead and highlight a few things right off the bat. So at Walmart, it costs $8 for 5 cans of soup. How much does it cost for 1 can of soup? Okay, so right off the bat, let's go ahead and write down a few things. So, what two things are we comparing? Well, we are comparing, go ahead and get a different color here, this to this. So we're comparing money to soup, or cans of soup, whatever you want to call it. Okay? And actually, I'm going to go ahead and change that real quick. I'm going to say cans instead. Cans of soup. All right, so we're comparing money and cans of soup. So now with the information that we have so far, we're given two different numbers here. We are given 8 and 5. And just like we talked about before in the previous chapter, we have to make sure we write these in the exact same order as they appear in the sentence. So it would be $8 over 5 cans of soup. And again, notice the money's on top, cans is in the bottom. We have to maintain this original ratio that we wrote down, okay? Money over cans. All right, so let's go ahead and continue. So now we're trying to set up a proportion here because we want to know how much does it cost for 1 can of soup. That's what I'm going to write next. So I'm going to go ahead and write a proportion. So this ratio equals another ratio, but it's up to us to identify where do we have to put that 1. Do we put that at the top or do we put that at the bottom? Okay, well, it says 1 can of soup, and the cans of soup are at the bottom, so I have to write my 1 at the bottom. Okay, so we want to know what the cost is. Well, if we don't know the cost, then we can always write an X. Okay, that's what we're looking for. And now we can go ahead and start cross multiplying just like we did in the past. So I'm going to go ahead and multiply these two, and I'm going to cross multiply these two. So what does that give me? That gives me 8 times 1 equals 5 times x. That's just 8 equals 5x. All right. Now what I have to do is divide by 5 because I want the x all by itself. So I get x equals 8 divided by 5. Now, let's be careful with that though, guys, because what are we talking about here? We're looking for money. So I can't say that something costs 8/5 of a dollar. I have to actually calculate that out. So in your calculator, go ahead and type in 8 divided by 5, and you should get x equals 1.60. Because remember, we're talking about money, so we have to write it in cents. So it has to have 2 units after the decimal. And remember, what did we just find? We found money. So this is $1.60 per what? Well, per can of soup. So per can. This is your final answer. Okay? All right. Now, again, what did we do? First off, we checked what 2 things are we comparing? We're comparing money with cans of soup. So I wrote my ratio, money over cans. All right, after I did that, I took the values that I was given, which were the $8, so I put that on top where the money goes, and I put the 5 in the bottom for the cans of soup. Once I did that, I set up a proportion because I want to know what the price per can is, so I put the 1 at the bottom and an X at the top because that's what I'm looking for. Okay, and once we did that, we cross multiplied like yesterday because we have a proportion, and we continued on from there by solving and isolating the variable. Okay, so just so we get a better understanding, let's go ahead and look at the next one, and then I'm going to have you guys try out a few on your own. Okay, so let's go ahead and read this problem together. So it says, Ricky drove 1,500 miles in 24 hours. So right off the bat, like before, I'm going to go ahead and highlight a few things. 1,500 miles in 24 hours. How far did he travel in 1 hour? Well, let's go ahead and write a few things down. Again, in words, try to write down what 2 things or what 2 types of units we are comparing. We are comparing miles, just as it's read right here, miles, and then hours, so that has to go in the bottom. All right, so this is a key thing to have on the side here, guys, because every ratio in our proportion that we're going to write has to follow that pattern. Miles on top, hours in the bottom. All right, so let's go ahead and see what information were we given. We were given that we had 1,500 miles over 24 hours. 24 goes in the bottom because that's where the hours go. Now we have to set up a proportion because we want to know how far did we travel in 1 hour. So where does the 1 go? Down at the bottom where the hours go. And we're looking for how many miles, so that will be our x. Okay, just like before, let's go ahead and solve this. So I'm going to multiply those 2 and these 2. And now once you get good, guys, you don't have to start doing this step that we did over here in parentheses. You guys can jump straight into it. I like to do it just so I know that I always put parentheses around it because I might have to multiply out a binomial. But if we get good at this, we can go and jump straight into it. So 1,500 times 1, that's just 1,500. 24 times x is 24x. All right, so let's go ahead and divide that out. Let's see. I want to get the x by itself, so I'm going to divide by 24. I'm left with x equals 1,500 over 24. But again, we want to know how many miles. We're not going to say 1,500 over 24 miles. So let's actually divide it out in our calculator. So if we do that, let's check it out. So we get 1,500 divided by 24. That's 62.5. Now, as my final answer, I have to be a little more descriptive. Oops. 62.5 what? What are we looking for? We're looking for miles. And remember, this is a ratio, so it's miles per hour. For exactly 1 hour is what we're looking for. Exactly 1 hour. Okay? All right, so this is our final answer. 62.5 miles per hour. All right. Let's take a look at 2 more, and then you guys are going to be doing 5 and 6 on your own. All right. So, next one. Lori received $225, and again, it used to underlining or shading or highlighting the key things that we have in this problem. So I like to do that right away first. So Lori received $225 for 18 hours of work. How much will she get paid for 1 hour of work? Okay, so let's go ahead and write my ratio in words first. I'm comparing, whoops, let me go back. Let me get my pen here. So let's see, what are we comparing? Comparing money and hours. So money over hours. Okay. Now, what two values were we given? We were given 225 over 18. So let's go ahead and write that. 225 over 18. We have to set up our proportion because we want to know how much for 1 hour. And hours goes in the bottom, so I'm going to put the 1 down there. And we are looking for how much money. So that's going to be my x. So again, let's go ahead and figure this out. So we cross multiply. That's just 225. Cross multiply 18x. Want to get this x all by itself, so I'm going to divide by 18. So let's go ahead and do 225 divided by 18. We get 12.5. Now, like I said before, guys, this right here would not be my final answer. I cannot leave that as an answer. Make sure you follow what you were asked in the problem. So my final answer would be x equals 12.5 what? 12.5 dollars per hour. Okay? This here is my final answer. Okay? If you were to write down this as your answer, guys, this would not be completely correct. This would take maybe half the credit. Okay? Because you figured out your answer correct, but remember, we're solving a real world problem here. We have to put some description to the numbers that we are finding. All right, last one before you guys do some on your own. All right, there are 6 ounces. So again, right off the bat, let's highlight a few things. 6 ounces of fat per, actually, I'm going to highlight this whole thing. Ounces of fat per 2.5 serving. Okay, how much fat is in 1 serving? Okay, so let's see. What are we comparing? We're comparing ounces of fat over servings. So we have to make sure when we write our proportion, we use ounces of fat on top, servings on the bottom. So first numbers we were given are 6 and 2.5. So 6 over 2.5. And again, 1 serving, well, servings is in the denominator, it's in the bottom, so I'm going to write my 1 there. And finally, my x at the top, because I'm looking for ounces of fat. So let's multiply these out. So what do I get? I get 6 equals 2.5x divided by 2.5. What do I get? I get x equals, or let's divide that out. 6 divided by 2.5 is 2.4, but again, I can't leave that as my final answer. I have to write a little bit more. So this is 2.4 what? We were looking for how much fat. So this is 2.4 ounces of fat per 1 serving. All right. Awesome. All right, guys. I think that is enough problems for now for you guys to try a few on your own and see if you guys actually understand this. So go ahead and pause the video right now and go ahead and try number 5 and 6. All right, guys, let's go ahead and take a look at 5 and 6 together. So let's go ahead and go a little bit quicker on this, especially since you guys have already tried these out. So let's figure out what we have already. So first thing I have, it says Ashley sent out 140 texts in a week. Okay, well, how many did she send in one day? Now we have to be careful here, guys. We are looking to see how much she sent in one day. But the original unit we were given was weeks. So how do we turn that into days? Well, there's how many days in a week? There's 7 days. Okay, so when we first write our two things that we're comparing texts over, and because our final answer has to be in days, I'm going to put this as days. All right, so we had 140 texts over in 1 week, but remember 1 week was 7 days. Now if I write my proportion, again, I want to know how many in 1 day, so I put my 1 at the bottom and my x in the top. All right, so let's cross multiply here. So what do we get? Let's see. We get 7x equals 140. Divide by 7, divide by 7. I get x equals what? What's 140 divided by 7? That should be 20. But 20 what? 20 texts per day. Okay, guys? Remember, this has to be between the two things that we are comparing. We are comparing texts and days. Texts and days. Okay? So let's just make sure we understand that. Whoops. Didn't mean to do that. I'm supposed to use the pen. There we go. All right, so 20 texts per day. All right, next one. Keep going. Let's keep this ball rolling. All right, so Pam played Candy Crush 120 times per month. Assuming there are 30 days this month, how many times did she play in 1 day? All right, so she's playing Candy Crush. So let's go ahead and write this down. So we want to know times played. And what do you guys think? Do we want to write months down here, or do we want to write days down here? Okay, I think we want to write days because look at our final answer. It has to be in days. All right. Okay, so let's go ahead and figure this out. So first thing we're given is 120. And we said we're going to assume that we have 30 days this month. So since she played 120 times in a month, and that month has to have 30 days, the 30 has to go in the denominator. All right, so our next ratio is how many times did she play in 1 day? So my 1 goes down here, and my x right over there. So let's cross multiply. 30x equals 120. Divided by 30, we get x equals 4 what? 4 times played per day. Once again, guys, two things that we compared: times played, days and days. Those are both on either side of this per. Remember, this is a ratio. We want to know a unit rate. Unit rate always tells us however much quantity per 1 day, 1 week, 1 whatever. As long as we have per something, okay? That's a unit rate. All right. So I hope you guys did well on those. So we're going to just continue on with these next two and move on to something a little bit more challenging. All right. So it says Joey traveled 165 miles in 3 hours. So right off the bat, 165 miles, 3 hours. I'm actually going to go ahead and write that right away. So miles and hours. Okay. It says how far did he travel in 4 hours? Okay. So let's go ahead and write down the information that we know. So right away we know that we have 165 miles over 3 hours. Now here we have not a 1 for my hours, but we have in this case a 4. We want to know how far did he travel in 4 hours. Okay, so we actually have to go ahead and figure out what our miles would have been. Okay, so let's go ahead and move on to cross multiplying these two. Okay, so I get 3x equals, let's see, 165 times 4. So you're going to set this up like this. Or 4 times 165. Let's figure out what that is. So 165 times 4 is 660. All right, we want that x by itself, so I'm going to divide by 3. But I have to do it to both sides, so I get x equals 220 what? Okay, so 220 what? It's actually 220 miles. And let's be careful here, guys. It said, how far did he travel in 4 hours? Okay, we want to know the distance. How far did he travel? This is saying we traveled 220 miles. Now, do I have to put 220 miles per hour? Well, let's think about that. 220 miles per hour, but we want to know how much he traveled in 4 hours. So per hour meant per 1 hour. But that's not what we have here. Here we want to know in those 4 hours, how much did he travel? So just this right here is a correct answer. That's not how many miles we traveled in 1 hour. That's how many miles we traveled in 4 hours. That's why we're not writing miles per hour. Okay? All right, let's move on to the next one. Let's see what we got. Amanda Snapchatted 33 times, so Snapchatted 33 times in 11 days. How many Snapchats did she send in 13 days? So once again, what two things are we comparing? We're comparing times Snapchatted, so I'm going to do SC, over the amount of days. Okay, so it was 33 times Snapchatted in 11 days. But we want to know how many in 13 days, so my 13 has to go in the denominator. And what I don't know and what I'm looking for is the times she Snapchatted. Keeping in mind that she Snapchatted the same amount. Okay, so let's cross multiply those two. So we get 33 times 13 equals 11 times x. So what is that? 33 times 13 is 429. Equals 11x. All right, so we have to divide that out. So we only want the x by itself. So what is our answer here? So we get x equals, all right, actually I'm going to go ahead and write this over here on the side. So we get x equals, let's see, 429 divided by 11 is 39. So again, 39 what? Well, let's see. We have in the numerator times Snapchatted, so this has to be times Snapchatted. So once again, I'm not going to write times Snapchatted per day because that wouldn't even make sense, guys. Because think about it. If it was 39 times per day, and on this first example, she tells us that in 11 days, she sent 33 Snapchats. Well, in 11 days, that would be a lot more. That'd be over 400 Snapchats. So that wouldn't make sense. Because this time, we're not being asked for a unit rate. We don't want to know for 1 day. We want to know for 13 days. Okay? So because we asked for 3 days, then our answer here is simply 39 times Snapchatted, okay, or snaps. All right, let's move on to the back side, and then we can finish off for today. All right, so once again, I'm going to go ahead and start highlighting a few things, and we can move on from there. Let me grab my highlighter, and let's read through this scenario real quick to see if we can make some sense of this problem. So it says, Blake still does not have unlimited text messaging. Okay, so his monthly texting limit is 100 texts. So I'm going to go ahead and highlight that. So his monthly texting limit is 100 texts. Blake sent 15 texts in 3 days. So right away I can start to see what I'm going to be comparing. It looks like it's going to be texts and days. So it says, if he stays at this rate for the entire month, assuming there are 30 days in this month, will Blake stay under his limit? Show your work and explain your reasoning. All right, so let's go ahead and try this out. So right away, from this information right here, I know I'm comparing texts with days. So let's go ahead and write that down. Texts over days. All right, so let's see. We have a lot of numbers here, guys, and honestly, we might not need one of them for our setup, but we will need that number for our final answer to help us out and get an idea and an understanding of what was being asked. Okay, so let's actually take these numbers that I do have here, because that's something we do know already. We know it's 15 texts in 3 days. Okay, now the question is, am I going to use that 100 or that 30? Well, let's see. It says his monthly texting limit is 100 texts, and we want to know if he keeps this rate of 15 texts every 3 days, will he go over that limit? So we just want to compare at the end with our final result if he does go over that 100 text limit. So I think what we're actually going to need to use is this right here. We're going to assume that there's 30 days in a month. So if he were to text all 30 days, which is what I'm going to put here, we want to know how many texts did he actually send after 30 days. Then we can compare it to our 100 text limit. Okay, let's figure this out. So I'm going to multiply this out, cross multiply. So what do I get? I get 3x equals 15 times 30, that's 450. I'm going to divide this by 3. I get x equals 150 texts. The text was in the numerator. So this is my answer for the question, but it's not the full answer because, let's see, that's how many texts he would have sent after 30 days. But what's being asked? It says, will Blake stay under his limit? Well, if he sends 150 texts, but his max he can send is 100, did he go over his limit? Did he stay under his limit? We would say no. Blake did not stay under his limit. He would have texted 50 more texts over his limit. Okay, because again, if he keeps that rate up, then he would have sent 150 texts in those 30 days. But his limit was only 100, so he definitely went over his limit. So he did not stay under his limit. Okay? All right, let's go on to one more, and then I'm going to have you guys try 11 on your own. All right, let's go ahead and highlight a few key things here. It says Zach only has 2 gigabytes of data each month. Okay? Zach already used 0.4 gigabytes in the first 7 days. If he stays at this rate for the entire month, assuming there are 30 days this month, will Zach go over his data package? Show your work and explain your reasoning using complete sentences. So, I hope you guys can tell right away here that we are comparing, gigabytes with days. So that's the first thing I'm going to go ahead and write. So gigabytes over days. Okay? Well, where do we see both of those things in the same sentence? Well, I see them right here. 0.4 gigabytes in the first 7 days. So that's the first thing I'm going to go ahead and write down here. So 0.4 over 7 days. And just like before, guys, we're trying to figure out if he will go over his 2 gig limit. That's a limit, guys. So we want to know in these 30 days, will he go over that 2 gig limit? So what I'm going to put down here is the 30 days because we're assuming there's 30 days in this month and we want to know if he'll spend or use up more than his limit of 2 gigabytes. So here I'm going to write down my X. I want to know how many gigs I'm going to use in those 30 days. All right, so let's go ahead and multiply these out. So let's see what we get. We get 7x equals, multiply 0.4 by 30. We should get 12. Let's double check that. I'll double check my work real quick. So 0.4 times 30, that is 12. Okay, so now I want to divide by 7. So I got x equals 12 divided by 7 is around 1 point, and I'm going to round a little bit, but 1.7 gigabytes. So this is my answer. So what was the question again? It says, if he stays at this rate the entire month after the 30 days, will Zach go over his data package, okay, or his data limit? Well, this is how much he would have used, 1.7, and this is his max. So did he go over his limit? No, he did not. So we would say no. Zach stayed within his data limit, or as it says in the problem, over his data package. Okay? He would still have how much data remaining? It looks like he would have 0.3 gigabytes of data remaining after those 30 days. Okay, so when I ask for a complete sentence, this is what I want to see. I want to see something to this effect. It doesn't have to be exactly like this, but you need to explain to me yes or no. Did he go over his data package or did he stay under? So you would say no, he did not go over his data package because Zach stayed within his data limit. All right, he would still have 0.3 gigabytes of data remaining after those 30 days. All right. So I hope this is starting to make a little bit more sense, guys. So what I want you guys to try out is the next problem on your own, and then I want to come back with you guys and make sure that we did this correct. Okay, so go ahead and pause the video for a second. All right, let's take a quick look at it. So it says Lori's goal is to lose 10 pounds in 8 weeks. Okay, if she already lost 2.4 pounds by week 2, if she stays at this rate the entire month, assuming there are 4 weeks this month, will she reach her goal? Okay, so again, what two things are we comparing here? Well, let's see. We're comparing, let's see, pounds, okay, and weeks. So pounds lost over weeks. Okay. Now, just like before, guys, we were trying to track a limit or a package. Now we are trying to track a goal here. Okay. So this is the goal that we want to reach. So once we have our answer, we want to see if we've reached this goal. So I'm not going to use that data just yet. I'm going to use this over here. Okay, I'm going to use this and this to start setting up my proportion. So let's see what we get. We get 2.4 over 2 weeks. Okay, so 2.4 over 2 weeks. And now our proportion says, let's see, if she stays at this rate for the entire month, assume there are 4 weeks this month. So 4 weeks this month, will she reach her goal? And then show your work and explain your reasoning. All right, so if there are 4 weeks, okay, in this month, I want to know how many pounds will I lose in those 4 weeks, okay? So let's go ahead and figure this out. Let's multiply these two. So I get 2.4 times 4. Let's see, 0.4 times 4, 9.6. And then I have 2x. So what do I get? I get x equals 9.6 divided by 2 is 4.8. Okay, so x equals 4.8 pounds. All right, now let's think about that, guys. This is how much she would have lost in 4 weeks. What we want to know is, will she reach her goal of 10 pounds in 8 weeks? So it's safe to assume that if this is what she lost in 4 weeks, then in 8 weeks, which is double that amount of time, then if we double this amount of pounds, which would in this case be 9.6 pounds, that still would not be enough to reach her 10-pound goal. Okay, so I'm going to go ahead and write in full sentences. Lori will not lose 10 pounds in 8 weeks. She can lose a total of only 9.6 pounds in 8 weeks. Okay, so she did not reach her goal. Very close, but she did not reach her goal. So again, I hope this started to help you guys out to understand proportions a little better. Now, we did a few real world problems, so I hope that you can see how some of the stuff that we're learning now is applicable to some stuff that we can try to figure out in the real world. Okay, even if it means just setting goals, anything like that, or budgeting or saving, things like that. Those are all applicable in these with math and this type of problem and proportion. Okay, so what I want you guys to do for the rest of this time is to go ahead and try out these problems. All right, I'm actually going to try out 2 with you, and then I'm going to have you try 2 on your own. All right, so let's go ahead and look at number 12. All right, so just a quick recap. All we have here is a proportion. So I'm going to multiply those out. All right, so I get 6. Remember, always try to write in parentheses to represent multiplication. That way you'll remember to distribute each time. All right, so I'm going to distribute those. Get 6m minus 30 equals 9m plus 9. Okay, after I distribute, I look to see if I can combine any like terms. Doesn't look like I can, but I have variables on both sides, and as I said, our rule of thumb is if there's variables on both sides, move the smaller one. Okay, so I get negative 30 equals 3m plus 9. Okay, I don't have any like terms anymore. All I can do now is continue with SADMAP. So I'm going to subtract 9. I get negative 39 equals 3m divided by 3. I get m equals negative 13. All right, cool. So again, let's keep going. Right away, I see a parentheses. I'm going to distribute. All right, so I'm going to rewrite this left side. Okay, whoops. All right, so let's see. Can I combine any like terms? Well, nothing on the left side I can combine, but on the right side, I could definitely combine those two. So I get negative 33 minus 5x equals negative 13x minus 25. Now I just have variables on both sides, so I'm going to move the smaller one. In this case, it's the negative 13, so I'm going to add 13 to both sides. Get negative 33 plus 8x equals negative 5. Now I have the variable on one side, so all I have to do now is use SADMAP. So any addition and subtraction first. I get 8x equals 8. Finally divide by 8. I get x equals 1. All right. So go ahead and try the next two problems out on your own, and we will come back and check to see if you did them correct. So go ahead and pause the video for now. All right, guys, let's go ahead and look at these two problems and see if we can finish up. So right away, I see the parentheses, so I'm going to distribute. So I get 4k plus 3k plus 9 plus k equals 20 plus 8k. My next goal is to go ahead and combine any like terms. You see some like terms here, and I think that's it actually. So 4k plus 3k plus 1k is 8k plus 9 equals 20 plus 8k. Now I have variables on both sides. I'm going to get rid of the smaller one. Well, they're each the exact same variable, so I'm just going to go ahead and cross those out. So I get 9 equals 20. Well, this is something we've seen before. And let me ask you guys this. Is this true? Is 9 equal to 20? No, that is never true. Okay? Because it's not true. It's not true. Then this has no real solution. This is my final answer. No real solution. Remember, guys, in order for this to have a real solution, it has to have either two numbers that are equal to each other, or we have to have the variable we find equal to exactly one number. Okay? But in this case, 9 does not equal 20, so we have no real solution. Whoops. All right, so let's go ahead and look at number 14 as our last problem. So let's go ahead and read what we have. It says, Lauren started out with 10 gallons of gas. Her gas decreased at a rate of 0.05 gallons per mile. If Lauren only has 2 gallons of gas remaining in her tank, how many miles has she driven? All right, so let's start to think about this, guys. So, again, she started out with 10 gallons of gas. Her gas decreased at a rate of 0.05 gallons per mile. So, this is starting to look a lot like a linear function. You guys remember your linear functions? It's y equals mx plus b. And if you guys remember from before, b is your starting value, m is your slope, or your another way to write that is your rate, okay? And y is just your, whoops, okay? Oops, let me get my green result. Okay, so let's go ahead and see what we can go ahead and substitute into our linear equation. So we have, she started out with 10 gallons of gas. That looks to me a lot like B, okay? Then it says her gas decreased at a rate of 0.05 gallons per mile. Well, that looks a lot to me like my n, right? It's our rate, it's our slope. It's going down, it's decreasing by 0.05 gallons per mile, all right? Now it says if Lauren only has 2 gallons remaining, okay, 2 gallons of gas remaining in her tank, how many miles did she drive? So it looks like we only have, let's see, let's go ahead and write down, well, first off, this 2 gallons, that's what's remaining. That's your result after spending all that gas. So I'm going to call that my y, okay? So let's go ahead and substitute all these values in here. So I get 2 equals, my slope was 0.05, but it's a negative because it's going down. And we're looking for that x because we have our b. Our b is 10, okay? Let's go ahead and subtract here. We're just using SADMAP, so I want that x by itself, so I'm going to get rid of that 10. I get negative 8 equals negative 0.05x. Divide by negative 0.05. Those go away, so I get x equals, let's see, if I type that into my calculator, I get 160 miles. Okay, so in this case, our x was number of miles, and this was remaining. Whoops. Let me go ahead and rewrite that. Remaining. Okay. All right, guys. I think we are ready to finish up this video. So this is the end, essentially, of chapter 1. So from here on out, it's just straight review. So I will see you guys for some of the next review sessions. All right. Take care.